Hi guys, so this is my second time trying to record a review. I'm so sorry it's a little bit delayed. The first time I was recording, I thought I was, but I guess I wasn't. So welcome Cambridge 2. I just want to let you know that exam 3 is looking a lot better than exam 2. I have a lot of students that are even doing better on exam 3 than exam 1. It is very, very important class that these exams are taken seriously because the only grades that you have are 3 exams, one gets dropped, and then your final. So your exams have is basically all your grade. So I just want to make sure that you know that through Canvas and with UT, that grade is very, very important. The grade that I have is just for high school, but that starts affecting your college transcript. So that's why I really want to push and make sure that you are reviewing and getting as prepared as you can for this exam. So for exam 3, guys, sorry, the original review was right before Thanksgiving. First, they start off with molar mass. Super easy, guys. I don't think you have an issue with this. So like for this one, we have fluorine, carbon, and nitrogen. So fluorine, carbon, and nitrogen, guys, basically you would just go to the periodic table, go to fluorine, carbon, and nitrogen. Your mass is here on the bottom. So you would just add that up and that would be it, guys. Whenever you have these little subscripts, it belongs to the element in front of it. So here I know I have 1 carbon, I have 1 nitrogen, and I have 3, 4, 5. I have 5 hydrogen, so I would multiply that mass times 5. This last one, they try to trick you with the charge for the ion. It has no effect on what you have. So for PO4, -3 or phosphate, I have 1 phosphorus. Sorry, guys. I have 1 phosphorus and I have 1 phosphorus and 4 oxygen. And that's it. You would go to the periodic table, multiply times the mass given there, and you'd be good. I think this is definitely one of the easier questions. Going back to our notes, 1 mole of any atom, guys, carbon, nitrogen, plutonium, gold, silver, cadmium, 1 mole of basketballs, 1 mole of myself, 1 mole of my son John Paul, or 1 mole of cake, right? They're all going to equal 6.02 times 10 to the 23 atoms. So that is a very important number that we need to understand, Avogadro's number. And for 1 mole, guys, whenever you're looking at grams, you're going to look at the molar mass. Again, it is exactly how you use the first one. You just go to the periodic table. In 1 mole of hydrogen, you will have 1.08 grams, 1.08 grams. For 1 mole of aluminum, you'll have 26.982 grams. So it's just the molar mass, guys. You find it on the periodic table. So this video, guys, what I'm primarily going over is the math part. So make sure that you practice it, that you work it out, and definitely plug it into the calculator yourself to check the work. So for the first question, how many moles of hydrogen are in a sample of 45.12 moles of heptane? So the setup for this one, guys, might look very similar. It's just understanding the question and what it's asking. So here, guys, we always start off with our given, right? They're asking for, or they give us moles of heptane. So I know I have 45.12 moles of heptane. So in 1 mole of heptane, guys, in 1 mole of heptane, I have to break it down further. How many moles of carbon do I have and how many moles of hydrogen do I have, right? So for every 1 heptane, I have 7 carbon and I have 16 hydrogen. I know the concept may be a little bit difficult for some, but just know for every 1 heptane, I have 7 carbon and I have 16 hydrogen. So this is going to help me, guys. Remember, we write our units across to cross out. So because I have moles of heptane there, in order for it to cancel out, I'm going to have moles of heptane here. So again, I know for 1 mole of heptane, I have 16 moles of hydrogen, right? So again, this setup, study it, practice it for the next question, and it'll be very easy on the exam. So all you have to do, guys, is moles of heptane cancel out with moles of heptane, and you're left with moles of hydrogen. That's what we want. That's how we know the setup is correct. You multiply across, guys. Make sure to practice it on the calculator, and you should get something like 721.92 moles of hydrogen. And that's it, guys. I want you to practice on your own the second question, and I'll provide the answer right now. So you can pause me here, practice the question on your own, and then check your work. Okay, guys, so let's check our work. How many moles of carbon are in 45.12 moles of heptane? So again, it is exactly like we did the first time. Let's set it up. So we know that our given is 45.12 moles of heptane. We are in the same situation as before. We know that for 1 heptane, I have 7 moles of carbon. So the way that I set it up, guys, remember, I need my units across to cross out. So I know that for in 1 mole of heptane, I have 7 moles of carbon. So knowing that, guys, you can solve. So moles of heptane cancel out with moles of heptane. I'm left with moles of carbon. Exactly what we did earlier. You multiply across, and your answer should be about 315.84. And now we're looking at moles of carbon. That's it for that type of problem, guys. Just make sure that you study it. Now for this next one is a little bit different. I had to go back and watch it again because the way that they solve this one is in a ratio setup. So it's a little bit different than our previous dimensional analysis setup. Here it's asking how many grams of oxygen are in atoms. So I'm given the atoms and I'm trying to find out how many grams of oxygen. The way that we'll set up this question, guys, make sure to study it, please. This is one that can get a little bit tricky. Is we have to first remember our conversion factors. We know for 1 mole of any element, here we're looking at 1 mole of oxygen. So for 1 mole of oxygen, we know that is going to equal 6.02 times 10 to the 23 atoms of oxygen. And we know that 1 mole of oxygen also equals the mass. So if we go to the periodic table, we go to oxygen, we have 15.99. I'm going to use 16 grams just because I'm rounding up. That O2, guys, is there to trick you or throw you off a little bit. Don't mind that. So I'm going to set this up in a ratio situation. I know that for 6.02 times 10 to the 23 atoms of oxygen, I have 16 grams of oxygen, right? Again, I'm trying to figure out how many grams are in 1.20 times 10 to the 24 atoms. So this is our setup. This is our ratio setup that we're going to solve for. So from here, what I want to do is isolate x, right? So I'm dividing by that value of 1.20. So I need to do the opposite to cancel it out. So I'm going to multiply times 1.20 times 10 to the 24 atoms. Because if I multiply, it cancels each other out. So I'm left with x by itself. But remember, whatever I do to one side, I have to do to the other. So make sure that you solve for this first. Put that in parentheses when you plug it into decimals. And then you're going to multiply that answer times 1.20 times 10 to the 24 atoms. And once you plug it into the calculator, guys, you should get an answer of about 32 grams of oxygen. Very simple, guys. Practice this question. Practice it again. You'll see something very similar on the exam. Again, it is a ratio setup for this one. If you caught on pretty early, guys, another easy way to notice this is, so here, 1.20 is actually 6.02 times 2. So what it's telling you is you have 2 moles of oxygen. So because you have 2 moles of oxygen, guys, what's the mass of 2 moles of oxygen? 16 plus 16 is around 32. So that's another shortcut way to answer this question. Next, guys, these are one of my favorites. It's a little bit more like your simple grams, moles, atoms. So how many moles of magnesium are in 2.02 times 10 to the 24 atoms of magnesium? So if you remember, grams, moles, atoms, grandma, GMA, Good Morning America. We're going from from atoms to moles. So this is a one-step equation. This is going to be pretty simple. So I set it up. So my given is atoms of magnesium, right? So that's where I'm starting off at. 2.02 times 10 to the 24 atoms of magnesium. So I know I'm starting off with atoms of magnesium. I need to find out my conversion factor. So I know for 1 mole of magnesium, I have 6.02 times 10 to the 23 atoms of magnesium. How do I know this? How is this something that I understand? So for this, guys, it's just a constant. We should know by now that 1 mole of any element equals 6.02 times 10 to the 23 atoms. So knowing this conversion factor, I can complete my setup, right? So here I have atoms of magnesium. Down here, I'm going to need atoms of magnesium so they can cancel out. And then I'm looking for moles of magnesium, right? That will go on the top. So that one cancels, that one's cancels. We're good to go. I just plug in the numbers. 6.02 times 10 to the 23 and 1 mole of magnesium. To check my work, guys, cancel out your units. They cancel out. I'm left with moles of magnesium. What am I looking for? Moles of magnesium. And you're good to go, guys. Plug it into the calculator. It would be 2.02 times 10 to the 24 divided by 6.02 times 10 to the 23. Solve for it, guys, and double check your work. You should get around 3.36 repeating moles of magnesium. This is probably the toughest that I get on the exam for math problems. Again, review the problems, practice them, write them on your own so you have that like muscle memory of it. And this one, guys, super easy. You just need to understand how to use the molecular geometry sheet. So AX4, 2, 3, all of that, you just have to know, okay, if I have an AX2, which is a linear, it's 180 degrees. If I have AX3, 120, a tetrahedral is 109.5. A trigonal bipyramidal is 120 and 90 degrees. And lastly, your octahedrals are 90 degrees. This one is pretty simple. So we know it's 109.5 degrees, 180 degrees. This is 120 degrees and 90 degrees. 120 degrees and 90 degrees. Again, it's just knowing how to use that molecular geometry chart. If you have any trouble using it, please let me know so I can help you understand how to use that chart. Lastly, guys, we're just going to draw a structure. So we know nitrogen will be in the middle. Nitrogen has 5 valence electrons. How do I know that? Again, I go back to my periodic table. Groups 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen is in group 5, so it tells me it has 5. And then I have chlorine. Chlorine is in group 7, so they'll have 7. If you remember clearly, in the end, this is what it's going to look like. You bond them because, you don't want anyone single. And that is your Lewis structure. So then you come up with your axe, right? So my axe A just always stays the same. I know I have a central atom. X tells me how many elements are bonded to it. So I have 1, 2, 3 elements bonded here. And E, for E1, tells me how many lone pairs on the central atom. This particular structure does have 1. So I have AX3E1. This is telling me that when I look for it on the molecular geometry chart, I look for AX3E. So I go down here, guys, AX3E. This is a tetrahedral. And let me explain this one a little bit better. So I know I have a tetrahedral in shape. It is 109.5 degrees. This one's actually going to be less than. So let me explain this one real quick. This lone pair has a lot of repulsion. So whenever you have a lone pair on the central atom, your bond angles are actually slightly smaller. So it's a little bit less than 109.5 degrees. Reason being that lone pair has a lot of repulsion. So it's just pushing and pushing and pushing down. So a more accurate description of this would be something a little bit more like this, because it's pushing those bond angles down due to the repulsion of the lone pairs. The shape is tetrahedral, but when it's looking for the geometry, guys, when you're looking for the geometry name, that's the one that they normally ask for. It is a trigonal bipyramidal. So the shape is a tetrahedral, but the electron geometry, sorry okay, I forgot. It's a trigonal pyramidal. That's about it, guys. Make sure that you look at the other review resources. Look up the Paris Climate Agreement. Write notes on it again. Look at the LE again. List the increased global temperature, and all of that should help you. If you have any questions, guys, please don't hesitate to reach out, and happy studying.